Hello everyone. In the previous video, we started creating our derived class, rectangle, and we implemented the three constructors for that class, two default constructors and a copy constructor. And here we highlighted that because we use data that's derived from this class, we can actually pass on some of the responsibility to our parent class, which is shape2D. And we get to take advantage of dealing with our attributes length and width specifically, and we let shape2D deal with it because that class already has code that is ready for dealing with the length and width attributes. So let's continue with the methods. We have used these three constructors and we are finished implementing them. Now we will implement these two methods here and these three operator overloads. So now we begin with the get area getter. And this should not be too different from what we've seen before in the previous video when creating rectangle as an independent method. This should be get area. Right, this implementation should not be different from when we created rectangle as an independent class. The idea is that now I don't have to do start from zero as I did with the independent class. I can focus on what's new, what's updated, and what's new and improved. Right, all I have to worry is that return the perimeter to get the perimeter, and I can focus on that itself. I don't have to focus on rewriting a get length and a get width because the parent class shape2D, which I inherit from, gets to deal with that for me. I only get to focus what's on new with the rectangle. Whatever's new, whatever new features I want to implement with this, and I like to view as rectangle as an additional upgraded implementation of shape2D, where we will be implementing more stuff in detail. Of course, this more stuff that we're implementing is simple. However, the idea is that when you have a class that can be implemented as a more specific implementation of another class, it's very important to have it as a derived class. So that way when you have an upgraded or better implementation of a generalized class, you can take that infrastructure and turn it into a specific application, which is what we are doing here by implementing rectangle as a specific way of implementing a shape2D class. And actually, I don't need to access the private data member itself. I can say set length and I can use that itself, right? Because I inherited that setter function from the parent class. So I'll call the get length. And something that you might see out in the wild is that you'll see something like this. If rectangle inherits from shape2D, I can also call shape2D. I can call that specifically. Here I'm calling specifically from my base class. This is an implicit method call to my base class because I don't have one defined here. I haven't overridden it. Here, however, what I'm doing is that I'm making an explicit method call to my parent class. So all that get width, that'll be rectangle get width. Right, so both of these do the same thing. Both of these do the same thing. The only difference is that this is an implicit function call for calling the set length method from shape2D, and this is an explicit method call for calling set width inside shape2D. With that being said, I'm actually going to copy this code here for updating the private data here, which is pretty good. Another alternative that you can think of is that we can override these so that way when we update these two attributes, we can automatically update that. We'll actually consider that in our next video when we create a new class based off of shape2d, but that is for later. So let's finish up implementing this operator, and we will continue with the plus operator and the double angle brackets operator. Here, as I call and overload the plus operator, I am adding some stuff that you may see in some programs. And again, this is highlighting the difference between making an implicit method call from a parent class versus an explicit method call for the parent class. So as we saw up here, when I called this set width, I made it explicit that I'm calling it from the parent class, and here it's implicit. So while you'll see this, and this is self-referential for the class itself, here what I can do is that I can kind of highlight the same thing. Let's look at temp.setWidth and temp.setLength. So here I'm making it explicit that we're calling the setLength method from shape2d. Here it's actually implicit that we're calling the setWidth from the shape2d class. And I keep highlighting that same difference. Again, this is explicit that we're calling it from the parent class, and this is implicit that we're calling it from the parent class. With rectangle, this rect as rectangle as an argument for this overloaded operator, I'm doing the same thing. This is implicit for calling getLength from the parent class from this rectangle, and here I'm making it explicit that I'm calling the method specifically from the parent class in this class. So while this does look confusing, this is something that you may see out in the wild. Now to move on to overloading the double angle brackets operator. Here this looks almost exactly the same as we had it for it as an independent class, so there's not too much of a big difference here. But one thing that I like to highlight is that if I build my solution, it works without any errors. So if we go back to main where we use rectangle and stuff and we launch our code, we will see that nothing is going to generate any errors because our rectangle class is able to successfully inherit from shape2d and do its operations as it should. Right, and this also shows that we can do something confusing like this and it can still work. However, for this example, I'm going to get rid of this so that way it looks like something familiar. However, you should know that this is possible, that you can explicitly call methods from a parent class and you can define it that way. So if you wanted to make it explicit that you're calling setLength, let's say overloaded by the rectangle class and not the parent class, I would have to write rectangle and the double brackets here. However, in this example, rectangle has not overloaded the setLength method, so we are not going to do that. In the next video, we are going to create a triangle class, and we are going to get into more details on overloading functions that we inherited with virtual, as you saw here. Here we did not really do anything with overloading from virtual. We did not override those functions specifically, but here we had the option to, and when we create our triangle class in the next video, we are definitely going to take full advantage of these being virtual methods and changing them to fit triangle, because as you may know, area and perimeter for a triangle is not calculated by multiplying the length times the width. Right, area for a triangle is going to be 1/2 of length times width. So because of that, we'll need to override the area and perimeter methods, so that way in our specific implementation of triangle, which is a 2D shape, we can do so with maintaining accuracy and integrity for the class. Thanks for watching, and we'll see you in the next video.